Okay, in this video, we're going to be talking about how to solve quadratic inequalities. So that would look like this. This is a quadratic equation, but instead of us asking to set it equal to 0, where we could just find the roots, we want it greater than. And I've actually used the same equation over here, but they're asking for less than or equal to 0, because I want to show you how these inequality symbols change your answer. So, of course, the first thing we need to do here is factor, because we need to know what our x-intercepts are. Where is this going to cross our graph? And so, if you need to watch the factoring video, do that. But 3 times negative 2 is negative 6, and factors of negative 6 that are going to give me a negative 5 are going to be negative 6 and positive 1, and then I'm going to put them over 3. And this one is going to reduce to negative 2 over 1. Again, if you're not comfortable with factoring yet, go ahead and watch that other video. So I'm going to have x minus 2 as one of my factors, and I'm going to have 3x plus 1 as the other. And we want to know, when is this greater than 0? Well, you have two options here. You can do a rough sketch of your graph very quickly to answer this, or you can do a sign chart. And I'm actually going to show you both methods. So in this case, we're going to look at our coefficient of our x squared term and notice that it is positive, which means our graph will be opening up. So if I was going to sketch a quick graph of this, I need to know what my x-intercepts are. So once we factor it, if we set this equal to 0, we get 2. And if we set this equal to 0 and solve, we're going to get negative 1/3. So these are the two places that it's going to cross the x-axis. Again, this is a rough sketch. So I'm going to call this negative 1/3, and I'm going to call this over here 2. Because the number in front of x squared is positive, my graph is going to go up. So I don't know any other points on it, but I know that roughly it's going to look like this. Once you have this rough sketch, you just need to go back to your inequality sign and figure out what it's asking you. It is asking me when this equation, which is my graph, is greater than 0. And greater than 0 means above the x-axis. So it is above the x-axis here, and it is above the x-axis here. So we could say that it's above the x-axis for any values of x that are less than negative 1, because notice this is kind of going to the left. Okay, that graph, if we kept going, was going to the left. And it is also above the x-axis for any values greater than 2, because this graph is kind of going to the right. The way we write this is we say x must be, notice my sign is going this way, less than this value that we found for x, negative 1/3. And here we would say, or x must be, since we're going to the right, we're going to point that way, greater than this x-intercept here, which is 2. And so this is my answer for this equation. When is this graph greater than 0? Okay, now I could do a sign chart. And the way a sign chart works is you still have to factor first. You still have to find these two x-intercepts, but we're going to list them in order from smallest to largest. So the negative 1/3 is the smallest, 2 is the largest. And we are going to take these two factors over here, and we are going to test them. I want to see if I didn't have this graph and I couldn't visually look at this function, then I want to know what's happening to it. So what we're going to do is we're going to pick a value to the left of negative 1/3, and anything to the left works. So I'm going to pick something simple like negative 2. If I plug a negative 2 into this x, negative 2 minus 2 gives me a negative value. I don't care about the value, I care that it's negative. Negative 2 times 3 is negative 6 plus 1 is also going to give me a negative. Then I'm going to pick a value in here, and the easy one between a negative and positive number is 0. If I plug in 0 here, I get a negative out. And if I plug in 0 here, I'm going to get a positive. Then I'm going to pick a number to the right of 3. 3 minus 2 is going to give me a positive value, and if I plug it in here, I'm going to get 10, which is a positive value. So what I want to do now is I want to see what happens for both of these factors, because what we're really doing is multiplying these factors together to get this equation or this function. So negative times negative is positive. Negative times positive is negative, and positive times positive is positive. So what we're asking ourselves now, if we didn't have this graph to look at, is when is this greater than 0, which means positive values. It's positive here, and anything to the left of it, and it's positive here, and anything to the right of it. So we would write our answer the same. X must be to the left of, that's this less than symbol, negative 1/3, and x must be to the right of 2. Be careful when you do this that you use these values. These values I wrote here are just for my testing purposes, but our answer is based on our x-intercepts, which are these two. Okay, in this graph, I actually gave you the same quadratic here. So we know how to factor it already. It's going to be x minus 2 and 3x plus 1. But now we're asking, where is it less than or equal to 0? So again, guys, we're going to have the same graph. I've got my negative 1/3 over here, and the reason I gave you the same thing was because I wanted to show you that this is very important, this symbol. We know that our graph is going to go up because this number is positive. And so again, I have this graph. But now they're asking me, where is this graph less than or equal to 0? And it is less than 0 below the x-axis. So that's what less than 0, where my y values are negative, and it would actually be equal to 0 at these x-intercepts. So notice that this is connected now. We could say that our function is below 0 for any x values between this point and this point. So we're going to put x between those two. And we're going to say less than or equal to here and less than or equal to here. When we connect things like this, we're always going to put the smallest value on the left, the largest on the right, and our signs will always go to the left. So this is my answer. Again, if you look at your sign chart over here, in this case we were asking when is it less than or equal to 0. Well, in that case I would be looking for this negative part here, because if it's less than 0 or if it's below the x-axis, then I want it to be negative. And we would have written it the same way. We would have put the x in here and used these two values. Okay, let's look at one more example. It's two examples, but I use the same quadratic. In this case, this is negative, so I want you to see that first, because what that tells you is your graph is going to open down, and that's going to be important. Okay, but we're going to do the sign chart first. And when we want to factor, we factor out the negative 1, and we get x squared minus 3x minus 10. And then when I factor this, I'm going to leave my negative 1 in front, but I'm actually going to get x minus 5 and x plus 2. Okay, so to do our sign chart now, we have to take into account all of these. Okay, we do need to find our x-intercepts. So if I set x minus 5 equal to 0, I'm going to get a positive 5. And if I set x plus 2 equal to 0, I'm going to get a negative 2. We always put the negative 2, or the smallest value, on the left. Here's my highest value. And we are going to test these out. Now, I have to account for my negative 1 out here. And then I have x minus 5 as a factor. And I have x plus 2. My negative 1 in every single interval is going to be negative. That's not going to change. But then I want to pick a number to the left of negative 2 to plug in here, and I'm going to use negative 3. And if I plug negative 3 in, minus 5, I'm going to get a negative value. And if I plug negative 3 in here, I'm going to get a negative value. Here, I'm going to use 0. That's an easy one between these two values. And 0 minus 5 is giving me a negative, but 0 plus 2 gives me positive. Over here, I'm going to use 6, which when I put it in x minus 5 with a 6 minus 5, I'm going to get a positive value, and 6 plus 2 is positive. So let's see what we end up with. Negative times negative is positive, times negative is negative. Negative times negative is positive, times positive is positive. Negative times positive is negative, times positive is still negative. Okay, so this is what our sign chart looks like. Now we got to go back and check our sign right here. We want to know when it is less than 0, which if we were graphing would be below the axis, but what we're looking for is this and this, because if it's less than 0, it has to be negative. Again, we're happening to go to the left here, so I'm going to say x must be less than this negative 2 value, or x must be greater than this 5 value. Okay? All right, on this one, the same function. So I really have this, and we don't have to necessarily write this out. And again, I get these factors, which are going to give me 5 and negative 2. Now, if you look at our sign chart that we've already done, we want this to be greater than or equal to 0. So we would be looking at this middle part here. And if this is in the middle, what we do is we say x must be between these two values, negative 2 and 5. Okay, see that's in the middle there, so I would just put x in the middle. Also, guys, this or equal to, these two just come from my original inequality. If this has an or equal to, then these will have an or equal to. So this is my answer if I want to know where is it greater than. But let's look at the graph. We know that it crosses at negative 2. We know that it crosses at 5. And because this was negative here, my graph should go down. So roughly, it looks something like that, okay? Let's make sure this is the same as our sign chart. I've asked on this one, where is it greater than or equal to 0? So that would be where is it above the x-axis or up to the x-intercepts. And it is above the x-axis between these 2 points. So I put x between them, okay? These are 2 methods you have to solve a quadratic inequality.